basic theory of multicast and the syntax, let's now go out to our topology and set it up. The first thing we want to do is to enable the routers in our topology for IP multicast routing. Also, let's enable PIM on the router interfaces. Let's begin over on router R2. On router R2, we go into global configuration mode and we globally enable IP multicast routing. With this command, we say IP multicast -routing. However, we also need to go enable PIM on the interfaces that we want to be running multicast, but that brings up a question. Exactly what kind of PIM, what mode of PIM, in other words, are we going to be running? Are we going to be running in sparse mode or dense mode? One approach is to configure an interface for sparse dense mode. Sparse dense mode says that this interface will run in sparse mode if a rendezvous point or an RP is available, but this interface will run in dense mode if a rendezvous point is not available. This approach can be really useful, by the way, when we're automatically discovering an RP. We run in dense mode just long enough to dynamically discover that rendezvous point, and then we switch over and start running in sparse mode. However, in this lab, we are deliberately going to be running in dense mode to begin with, and then we will hard code sparse mode operation. So let's configure our interfaces for sparse dense mode operation. Let's go into interface configuration mode for Fast Ethernet 0/0, and we say IP PIM sparse dense mode. We go into interface Fast Ethernet 0/1 and we give the same command, IP PIM sparse dense mode, and we're done on R2. Let's go over to R1. On router R1, let's globally enable multicast routing. We say IP multicast -routing. Then we go into our interfaces and enable PIM sparse dense mode for those interfaces. Let's go into interface Fast Ethernet 0/0 and say IP PIM sparse dense mode. And we have a couple of sub-interfaces, you might recall, built on serial 0/0. We need to enable PIM for each of those sub-interfaces. Let's go into interface serial 0/0.1 and we say IP PIM sparse dense mode. Let's go into interface serial 0/0.2 and once again say IP PIM sparse dense mode. And we're done with our initial configuration on R1. Let's go give a similar configuration on BB1. First, let's enable multicast routing, IP multicast -routing. We go into interface serial 0/0.1 and we say IP PIM sparse dense mode. And we do the same thing for serial 0/0.2, IP PIM sparse dense mode. And we're done on BB1. One router to go. Let's go over to BB2. We get into global configuration mode and say IP multicast -routing. And for our two sub-interfaces, let's enable PIM. Let's go into interface serial 0/0.1 and say IP PIM sparse dense mode, and interface serial 0/0.2 IP PIM sparse dense mode, and we are done with our initial configuration. However, at this point, we don't have any multicast sources configured. We don't have any multicast receivers configured. So without any multicast traffic coursing through the veins of our topology right now, let's check out the state of multicast in our routers. Since we're on BB2, let's go ahead and say show IP PIM interface. And from this output, we can see which of our interfaces are running PIM. Here we have interfaces serial 0/0.1 and .2. We're configured for sparse dense mode, you can see. Another command we can issue is show IP mroute. This is going to show us our IP multicast routing table. And even though we don't have any multicast sources or receivers configured at the moment, we still have an entry in our IP multicast routing table. Notice that in parentheses we have an asterisk a star, then we have a comma, and then we have the IP address of a Class D multicast group, 224.0.1.40. This entry in parentheses, this is called a star comma G entry. The star represents the source, and the G represents the group, which in this case is 224.0.1.40. The reason we have this star comma G entry for this IP address is that 224.0.1.40, that's the IP address used by Cisco for auto RP discovery. And that's where we don't statically configure the IP address of a rendezvous point. However, in this lab, we will statically configure the RP address. Another type of entry that we might see at some point in our multicast routing table, besides a star comma G entry, is an S comma G entry. The S is going to show us a specific source that's sending traffic for the specified group. But here we don't have a source, so we just have a star comma G entry. Let's go over to BB1. Let's check out its current state. We do a show IP PIM interface, and we can see that we have similar output. We are again configured for sparse dense mode on these interfaces. If we go over and issue the show IP mroute command again, we'll see that we still have that star comma G entry. What about router R1? On router R1, if we do a show IP PIM interface, we should have 3 entries, and indeed we do. If we do a show IP mroute, again, we just have that single star comma G entry, and just for completion's sake, let's go over to router R2 and do a show IP PIM interface. A couple of entries, and we do a show IP mroute, and we have that single star comma G entry. Now, let's add a receiver. This receiver in the real world might be a PC running an application that goes out and says it wants to join a multicast group. But in this lab, what we're going to do is we're going to make interface fast Ethernet 0/0 here on router R2 act as a multicast receiver. We're going to tell this router interface that it is a member of group 239.1.1.1. Here's how we can do that. We go into global configuration mode and then into interface configuration mode for fast Ethernet 0/0, and we say IP IGMP, the Internet Group Management Protocol, join -group 239.1.1.1. We're saying that we want this interface to participate in and receive traffic destined for the group 239.1.1.1. Let's see what our state looks like now on other routers. Let's go up to router R1. Before it had a single star comma G entry, as we see on screen. But now, let's do a show IP mroute. And this time, we have a star comma G entry for 239.1.1.1. But the star tells us that we don't know about a specific source. But if we do learn about a source for this multicast group, R1 knows that it is attached to a multicast receiver that wants to receive traffic for that group. And by the way, we know that this router is directly attached to a receiver because of this C flag. Notice the C flag, if we scroll up just a bit, the C flag indicates that we are connected to a receiver. Also, the D flag, that indicates that we are running in dense mode currently. Let's go over to BB1. Over on BB1, let's do a show IP mroute. And here, notice that we don't have knowledge of that 239.1.1.1 group because BB1 does not have any directly attached multicast receivers that want to receive traffic for that group. What about BB2? On BB2, let's do a show IP mroute. And similarly, BB2 does not have knowledge of the 239.1.1.1 group. Now, let's create a source for this group. Specifically, let's go over to BB1 and let's ping that IP address. Let's just do a ping to 239.1.1.1. That's going to create traffic destined for that group. Let's issue a ping. It will issue a single ping when we ping a multicast Class D address. And we do have a reply, so it was successful. Now let's go over to router BB2 and once again issue a show IP mroute. And let's see what this output is telling us. Notice that we now have